Hi, Algebra 2 students. We are going to review exponential functions. Okay, so what is an exponential function? An exponential function is in this form. Y is equal to a times b to the x minus h power plus k. Okay, so an exponential function typically looks something that looks like this, where it's going to swoosh up, okay, or swoosh down. Now, typically swooshing up like this, okay, this one right here, this is an exponential growth function, and swooshing down is an exponential decay function. Now, these can be reflected. Exponential growths can be reflected over the x-axis, and decay can be reflected over the y-axis. So they don't always look like they're swooshing up or down, and that's why I said typically. What makes something an exponential growth function versus an exponential decay function? By looking at the function. Well, you want to look at this b value right here, okay? If this b value is greater than 1, we have exponential growth. If this b value is between 0 and 1, we have exponential decay, okay? So let me just quick review with you what are the steps for graphing these exponential functions. And then what I'm going to do is I'm going to take a look at the review. I'm not going to do all the problems with you, but I'm going to just take a look at the review and go through some questions to make sure you understand how to apply them to certain scenarios. Okay, so what we usually do is we start out with this table that we filled out that we learned when we talked about this lesson. So our x values are -1, 0, and 1. Our y values are we take a divided by b for that y value, 0 and whatever that a value is, and 1, and then we take a times b, okay? And we always have an asymptote at y is equal to k, whatever that k value is. So that's the first thing. We fill out the table just as is, okay? Right? The next thing that we want to do is we want to change the table, and we want to look at these h values and these k values. So if you have something in the exponent, so like an x plus something or an x minus something, that's that h value. And what you want to do is you want to take that h value and you want to do the opposite, okay, to the x, okay? And then, so it's the opposite operation to the x. So since I have a subtraction of h there, I put an addition of h right here, okay? And then to the y value, okay, you take this k right here, and you change all the y values by doing the same operation to y, okay? So that's why I put plus k there, because I have a plus k here as well. All right, then we're gonna graph our points as well as the asymptote and state our domain and range. So let's go through a couple questions right now just to make sure that you're pretty fresh on this stuff. I'm going to skip through the matching right now, and I want to go right to some of these graphing questions, okay? So let's start with number 9, okay? On number 9, I have y is equal to negative times 2 to the power of x. So I'm going to put a -1 right here. There's a little invisible 1 right there, okay? And what I'm going to do now, okay, and if you look back, you say, okay, we have in our graph, we have -1, 0, and 1 in our table. -1, 0, and 1, okay? And let's just rewrite that table there so we don't have to keep going back and forth. -1, 0, 1, and we have a divided by b, a, and then a times b. Okay. All right. So we want to identify what our A and our B are. So this is our A right here, -1. And this is our B right here, 2. Okay. So -1, I want to do A divided by B, right? A divided by B. Okay. So that's going to be -1 divided by 2. Okay. -1 divided by 2, which is going to give us a -1/2. Okay, and then for the 0, right, 0a, so that's going to be 0, -1, okay, and then 1, I'm going to take a times b. So a times b is -1 times 2, so that gives me -2. And then our asymptote is always equal to y is equal to k. And our k value is whatever added on the outside here. And we don't have anything added on the outside, so our asymptote is that y is equal to 0. Okay, so step 1, we wrote down the table. Now step 2, we need to change. Now I don't have anything going on in the exponent, and I don't have anything going on out here, this k value, so I don't have to do anything. So now I'm on to step 3. Y equals 0. So y is equal to 0 right here. And this is a horizontal asymptote. And now I go to x is -1 and y is equal to -1/2. So 1, -1, -1/2 right here. Okay. Then we have 0 and -1. Okay. And then we have 1, -2. So 1, -2. Now, what happened was this negative, we have an exponential growth function. How do I know that? I know that because this b value here is greater than 1. So typically our exponential growth function goes up like this. Well, our points don't look like that should happen. So what actually happened here with this negative value is it reflected all of our values over the x-axis. And so now what that exponential growth function does is it looks like it's going down like this instead. Okay, so now what I'm going to do is I'm going to erase this right here because that's not the actual problem. I just wanted to show you why it was going down like that. And we have to talk about our domain and our range, and our domain will always be all reals. And then our range is talking about all the possible y values. If you go up and down, you'll notice you don't have any y values. You have no graph up here above this line. They're all below that line. So we say y is less than or equal to 0 for our domain and our range. Let's do another one where we have to transform it, okay? So we can look actually at this one right here, number 12. I think that's a good one, okay? So just a friendly reminder. We always have -1, 0, and 1. A over B, A, and then A times B, okay? So I'm going to make my table, step 1. I have -1, 0, and 1, okay? A over B, okay? So A divided by B. Well, this is my A right here. This is my B. So I'm going to do 3 divided by 1/2. Well, that's a compound fraction. That can't happen. So I can plug that in my calculator if I want, 3 divided by 1/2, or I can do it in my head, whatever happens. But 3 divided by 1/2, if you put that in your calculator, that actually gives you 6. Okay. Now the second one, 0A. So here's my A value again, just a friendly reminder. And here's our B value, okay? So that's 0A, okay? So my A value is 3, so 0, 3. And then finally, 1 is going to be A times B. So I take 3 times 1/2. And 3 times 1/2, if you put that in your calculator, that's 1.5. And some of you don't need to put that in your calculator. You know it, others do. It doesn't matter, okay? So that's step 1, right? Filling out that table. Step 2 now is changing the graph. And now we have stuff going on the outside, okay? Let me really quick rewind. Let me just adjust the asymptote. Is always y is equal to k. And this is our k value right here, okay? Okay, so that would be y is equal to -1. Step 2, what I want to do is I want to change the table, okay? So I want to look at the exponent here. And remember I said in the exponent, we do whatever's the opposite operation is to the x values. So we see subtraction of 4. So I actually want to add 4, okay? So I'm going to take -1 plus 4, which is 3. And I like to cross this off now because I'm done with it. 0 plus 4 is 4, okay? And 1 plus 4, that's 5. So I'm done with that part. I looked at the exponent. Now I want to talk about this k value. The k value, we do the same to y. So that same operation to y. So I'm going to subtract 1 from all the values. I'm going to take 6 minus 1 is 5. 3 minus 1 is 2. And 1.5 minus 1 is 0.5. Okay, so step 2 is done. Now what I want to do is I want to graph these values. So these are my new x values as well as my horizontal asymptote. So I go to -1. I make a horizontal asymptote going through it. Okay, X is 3, 1, 2, 3. Y is 5, 1, 2, 3, 4, 5. X is 4, 1, 2, 3, 4. Y is 2, 1, 2. X is 5, so 5 is right here. Y is 0.5. Okay, so now how is this graph going to look? We know that this is exponential decay because this B value is in between 0, okay, and 1. So what that means is I'm going to have a graph that's swooshing down. So I'm going to go just like this. Okay, and so now we look at this and we say, okay, the domain is always going to be all reals. Okay, and the range now is up and down, our Y values. And if you notice, we don't have anything that is in this area. All our Y values are above this -1, okay? So what I want to do then for that range is I want to say Y is greater than -1, okay? Now what I want you to notice over here is we have this E over here. Nothing changes with E other than you need to change E to the approximation of what that E value is. So we want to rewrite this as 3 times 2.7 to the X power. Okay, so everything really does stay the same. All your steps stay the same. It's just change that E to 2.7 for your calculations. Let's go ahead and quickly do this E problem just so you're a little familiar with it, okay? And what I like about this problem is there's no A in front of it. So I have E to the X. This, whatever is like, I like to say in class, like touching the exponent, that's your base, that's your B. If there's anything else, like this 3 right here, this is not my B, that's my A, that's the number. The E is my B, so I have my A and my B value, right? And the B is like whatever's touching that exponent, I like to say. The X is not touching that 3. The X is only touching the E, okay? Similar here, the X is touching that 1/2. It is not touching that 3, okay? All right, so let's look at this and we say, okay, we have E to the X power. Okay, so step 1, make your table. We have -1, 0, and 1, okay? And I'm just gonna fill out the table with you guys in this one. I'm not gonna actually graph it, I'll let you guys do that. We know that our asymptote is that Y is equal to 3. How do I know that? Because that's my K value right here, okay? And now I know that I have A divided by B. So I'm going to rewrite this E as 2.7. Well, what's my A? I don't see an A there. So what that means is it's actually 1. So 1 times 2.7 to the X power plus 3, okay? All right, so when we have A, or -1, excuse me, we take 1 and we divide it by 2.7. Why do we do that? Because 1 divided by 2.7 is A over B. And that gives us 0.37. With X is 0, okay? That's when we take whatever the A value is. And our A in this case is 1. Our B is 2.7. So 0, 1, okay? And then 1A times B. So we take 1 times 2.7 is 2.7. Next, what do I want to do? I want to look and see what, I want to change the table, right? Well, there's nothing going on in the exponent. It's just the X. So that means nothing happens to these X values. But on the outside here, I have a plus 3. So I'm going to add 3 to each of these values. So 0.37 plus 3 is 3.37. Okay. 1 plus 3 is 4. And 2.7 plus 3 is 5.7. So here are our new values. Okay. Lastly, what I want to go through with you guys is just a review of word problems. Okay. So we have 4 different formulas here. And you really are just doing what we call plug and chug. So you're plugging in values. You just want to make sure that you're plugging them in the right way. So to keep this video on the shorter side, let's kind of wrap all this up. But this first formula here is an exponential growth problem. This one is an exponential decay problem. This one is called a compound growth. And this one's called a continuously compounded growth. Okay? So how do I know which formula to use for which word problem? It really is just about deciphering what the words mean. So we deposit $500 into an account that pays 5% annual interest compounded continuously. So they tell us that it is compounded continuously. So continuously compounded right here, you guys. CC. What is the balance after 3 years? So let's talk about what all of these letters mean. A capital A means what you end with or your balance, okay? Okay. A little a lowercase a, is your starting point. And with capital P, that's really essentially the same. It's just your investment, how much money you invested at the start. So the start of the investment. Okay. Your R is your rate. And the important thing about the rate is you need to change the percentage to a decimal. Okay. And how I do that is I need to either move the decimal back 2 to the left, or I need to take what they give us here and divide by 100. Okay. So divide by 100 to get that decimal. And then the T is your time in years. And the last thing here, we see N for this problem, and that's how many times a year the investment is compounded. Okay, so I'm not going to type all these in the calculator with you, but I will set them up with you, okay? And what I will do is you can practice this on your own, and I will post the key, and so you can check your work to make sure you're doing it right. So you deposit $500 into an account that pays 5% annual interest, compounded continuously. So I know I'm using A is equal to P, E to the RT. I want to find the balance, that's A, okay? Or the ending, okay? P is my initial investment, so that's $500. E, now I'm going to change that to 2.7 to the R times T, okay? Well, R is my rate, so I need to divide by 100 to give me 0.05. So I'm going to put 0.05 times 3. Now, it is important to know when you're using your calculator, really follow your order of operations or making sure that you're typing it in correctly. So I would suggest that you pause it, try this on your own, and make sure you get the right answer based off of the key, okay? Or you could just open up the key as well and type them out and make sure it matches up, okay? Number 16, you invest $2,000 in some stock in the year 2016 that you assume will increase at a rate of 3% over the upcoming years. What will it be worth in 2023? Okay, now here's the big deal. They don't talk about anything about compounded. So right away we can cross these problems or these formulas off because there's no word compounded in here. Now you have to decide, is this growth or decay? Well, we are hoping that we are growing, right? Because it's saying increase, okay? So let's fill it out. We want to know what's the balance. What will be the ending value? Little a, that's your start, okay, or your start of your investment, right? So we started with $2,000. Then we see we have 1 plus R. Well, R needs to be divided by 3, so 3% divided by 100 gives me 0.03 to the T power, okay? So to the T power, so how many years is that going to be? So if you think we have 16 years all the way to 23, okay? So 16 to 23, so 16 to 26 would be 10 years. So subtract 3, so that's 7 years right there, okay? So that's how long the time is. If you didn't know how I did that in my head, you could just take 2023 minus 2016, and that gives you how long it's invested for, and that's going to be 7, okay? All right, so I'm going to put to the 7th power, and again, I would just say practice quickly typing things in just to make sure it's right. Oopsie, let's look at number 17. 17, you bought a car for $9,000, but it will depreciate at a rate of 10% each year. What will it be worth 5 years from now? Again, it's important to note that you do not see the word compound in it, so you're going to cross off compound growth and continuously compounded. So now we have to decide, is it growth or is it decay? Now there's a word in here that not everyone knows, and it's depreciate. That means go down. So that means we're using the decay formula. We want to know how much it will be worth. We initially started with $9,000. It will go down 10%, so divide by 100 to the fifth power. Okay? 9,000 times 1 minus 0.10 to the fifth power. And then finally, 18. This one's compounded quarterly. Okay? So that means it's not, it will say continuously compounded if you're supposed to say that. Since it doesn't say continuously compounded, you're using continuous compounded growth, excuse me. Okay? So let's start with our initial investment. Our initial investment is P, that's $200. Okay, whoops. Times 1 plus R over N. Okay? 1 plus R. Now my rate, here's the thing I've noticed some kids, they'll say, oh, it's already in decimal form because they see a decimal, but it's not because it's got that percentage on it. It's 2.5, it's 2.5%. So we need to divide by 100 to get that R, and that's going to give me 0.025. Go back up to the formula. So we have our R divided by N. That's how many times a year. How many times a year? If it says quarterly, that's 4 times a year. Scroll back up. All to the N times T, okay? All to the N times T. So that's how many times per year, okay? Times the time. All right. So I'm going to take the times per year. Times per year is 4. And then the T is how many years? That's 6, so 4 times 6. Okay, plug that in your calculator. That will give you the answer. I want to just quickly, I know I'm getting long here, I'm sorry. I want to quickly just show you the matching. The matching is just saying, hey, can you understand how to graph that? And just some helpful hints, like you can go ahead and graph each one of those if you want. Or you can say, hey, I know I have growth here. How do I know I have growth? I have growth because this B value is over 1. Okay, now this, what does this negative value do? What that does is it flips it over the x-axis, okay? I have no H or K, okay? And so you can go and you can use process of elimination to figure these problems out. If you have any other questions, let your teacher know, and good luck on catching up on this unit. You guys have a great day.